Yo, what up? Welcome to Made by Ozzy. I'm Ozzy. This is my dog Copper. This is going to be a different episode. I just want to talk about some of the ramifications of choosing RS232 for the communication protocol for something like a crypto miner and a GPU. Um, there's there's some trade-offs that are going to happen for it. I just want to take some time. I was trying to work this into the next video of how to, when we actually set up the Verilog module to receive bits over RS32. But I mean, I just want to keep these videos more manageable. And this, honestly, there's a lot to, you really want to understand what we are going to do and what the trade-offs are with choosing RS32. It's honestly really, really slow. 115.2 kilobits per second is, we're in days of age where 10 gigabit Ethernet is sort of standard. It's what you expect to see. So we're, 6 orders of magnitude below that. That's there's a trade-off to everything, right? So why even bother with something so glacially slow nowadays? The the straightforward answer is it's super easy. It's the easiest one. There's no going around it. It's going to take the least amount of logic on our hardware. It's basically every single microcontroller that exists supports it. It's super easy to add to any PC. And most of all, it's easy to understand and explain, and we can get to a point where we could use something quickly, very quickly. More modern communication protocols, like USB is something that comes to mind. That's not really normally an FPGA friendly type of communication protocol because there's a whole lot of bus management. You need a lot of supporting RAM and registers to actually support a USB protocol. And it's not normally a wise economic decision for FPGAs, mostly for the amount of fabric it would take up versus the utility it would provide, and because it takes up a lot of fabric, and if you plug it into one USB device, it's not really worth it. USB is great because it's so easy to expand, and it's not a big problem on PCs because they're huge, and it's okay. But on FPGAs, you usually want the hardware for something else, not for your communication. So that's one big benefit of RS232 is it's going to leave a small footprint. Keep in mind, when we're programming FPGAs, we're taking up physical space on this chip. We can't just go adding as much as we want. We're going to fill it up. And so if what we want is a GPU, if what we want is a crypto miner, we don't want a really sick USB controller. So that's something to keep in mind. What is much more commonly used for fast speed on FPGAs is PCIe or PCIe Express. And that's a good protocol. It's definitely the one I'd want to implement if I had a PCI Express slot on this dev kit. I don't. No cheap dev kits have PCIe built in. Also, I don't necessarily have a PCIe slot available on my laptop. You could get like a riser, a little adapter. But I do want to develop that one day. In fact, I have sort of plans of buying a little Latte Panda single board computer. It has an Intel processor on it, so it could run a Linux distribution or Windows. And it has a PCIe slot. And I was thinking it'd be really sick to get a Squirrel FPGA card and actually try and get a PCIe communication channel running. But we'll see. We'll see if this sort of grows and becomes popular. But anyway, circling back to the speed ramifications of RS32. It's super easy. That's why I want to do it on a channel, and obviously where we're started. What will it let us do as far as crypto mining and GPU? So what do those things actually need? So crypto mining, we're obviously going to get into the details because there's a whole lot of things to cover how it all works. But the main takeaway is you may be familiar with the term block time if you're familiar with blockchains. You have a Bitcoin has a 10-minute block time. Other blockchains like Digibyte, which we're going to be working with, has a 15-second block time. So what miners actually do is they are competing to get into that block. So theoretically, a miner only needs to receive information every block because it's just working to try to get back into it. And the main information that the miner needs is the previous block info, hence blockchain. The transactions coming in will change, but the frequency of which will probably likely more then obviously the 10 minutes. But that's up to the miner's discretion, and you won't. Every time a new transaction gets broadcast to the mempool, which is the list of transactions that are waiting to be processed on a blockchain, it doesn't immediately. Not every miner is like trying to grab every single one. So if the actual transaction data that you're trying to process will likely not change very quickly. It'll likely only change once every second, which is honestly much faster than it will actually change. From my experience with the new work data that you receive from mining pools, is much slower than 1 second, even for a blockchain like Digibyte, which has a 15-second block time. So we're only going to get new data once a second. Let's keep that in mind. What data are we going to get? And I'll tell you again from experience, it's only 640 bits, not bytes, bits. 640 bytes would be times 8, right? But bits. So 640 bits once a second. Our RS232 protocol can cover 115.2 kilobits per second. It's actually kilobaud. Keep it in mind that the overhead of the start and the stop bit drop off 20%. So we're actually at like 80 kilobits per second, something like that, right? So regardless, 80 kilobits is a lot faster than 640. For crypto mining, RS232 is plenty fast. It is plenty fast. There's not a whole lot that needs to go back and forth between the controlling software and FPGA hardware. So crypto mining, we're actually all set. RS232, great choice, no problem. For graphics, we're making a huge trade-off. Graphics require a lot of data transfer between the controlling PC and the hardware executing the graphics. This is predominantly in the form of vertexes, which describe the characters being drawn on the screen. Everything's made up of triangles, triangle here. And so that data needs to get written out to the GPU. And that's one way data gets written out. Normally, you would want to describe or write all the vertex data out to the GPU once, and then manipulate that data with much smaller MVP arrays, model view projection, basically transformation arrays. They take this vertex data you already wrote. I wrote out all the triangles which describe copper here. And then I'm going to lift him up in the air or something. I would describe that translation of all the existing vertex points with a matrix. So normally, you can get away with a GPU by first pre-writing all the vertex data. If we ignore that part from our speed, we are going to try and hit a goal of 30 frames per second. 30 frames per second. That's not super high end, right? But it's by all means achievable. If we're trying to hit 30 frames per second and our speed is 115.2 kilohertz or kilobits per second, then in one frame we could send about 3,800 bits. So we don't actually care about bits, right? We care about how many numbers can we send over. So 3,800 bits, that's divided by 32, because that's how many bits are in a float, right? So that's something like 120. But if you chop off the 80% because of the overhead of RS-32, we're somewhere 90. Let's call it 90 floats that we can send in one frame. So if we want to only send enough floats to move a vertex in space, or a vertex array in space, we usually have to send a 4x4 matrix. So that's the model view projection matrix, or translation. I say translation, that's incorrect. But the model view projection matrix is 4x4, so that's 16 values, and we could have about 90. So if we want to hit 30 frames per second, we can send... so 90 divided by 16, I don't know, 5 or 6. We could send something like 5 new MVP matrices every frame over this RS-32 communication protocol. That's decent. We're not going to make the world's next leading graphics card with that with that much of a limiting factor as far as data transfer and bandwidth there. But it's gonna give us something that we could really play with. We could see something happening in real time. We have the benefit that we have the VGA output on the FPGA, which we're gonna code up on the channel coming up soon. There's a million things to do. There's a million things I haven't done, but just you wait. Yeah, if you guys haven't watched Hamilton yet, give it a watch. Um, Okay, so I really just wanted to have that talk, take these few minutes, and really explain to everyone watching and keeping up with the channel that RS232, it's slow. Don't expect the world from it. It's gonna give us everything we need for crypto. We're gonna have to settle for a good learning experience with graphics, but it's a tool. It's gonna teach us. It's gonna give us all the tools we need to learn much more. So, all right. Okay, so I know this is sort of like a weird video, right? Because I didn't do any Verilog coding or anything. And I just, sat here and talked at you for a little while. But I really wanted to set aside some time to make sure that, what we're going to be able to achieve with R32 is well understood. And, I let me know what you think about, this sort of style of taking just a break from hard coding to sort of explain the overview, the top level. Like this is the sort of thing I'd be doing if I was sitting down in a meeting at work, and trying to explain to fellow engineers a topic. This is what would happen, right? So let me know what you think about this, and please hit like, please hit subscribe. That really helps me out. It's great just to know that people are listening and getting something out of this. I really want to be able to impart this knowledge on people. All this stuff is, if you know the first steps, it's not a huge leap to get there mentally, and a lot of people just, it's tough to take the first step, but once you get past the first step, a lot of it just becomes the intuition starts, growing, and I just, I mean, if you're on this journey with me, then thank you so much for watching, and hit like and subscribe. Thank you.